Let's talk about this paper from UBCom 2019 about depression detection using contextually filtered features. So their main contribution is a new way to engineer features, and they use association rule mining to capture routine behavior and extract the contextually filtered features. So on a high level, they obtained this sensor features from smartphone and Fitbit sensors. And after extracting the features, they split the dataset into two parts. So one part is used for mining the association rules, and second part is used for extracting contextually filtered features using these mined association rules. So once we have these features, the machine learning model is built, trained. And as a ground rules, like BDI questionnaire score is used, which is obtained by self-report from the students twice, in the beginning of semester and in the end of the semester. So now let's talk about what is the difference between Unimodal and contextually filtered features. Unimodal features are normal features, which were used up to before this work. So the example is, for example, how often student is sitting in a classroom in one day is one feature. So actually this is, so they have 10, let's say they collect the data for 100 days, because that is one semester. Then this feature is averaged. The mean and standard deviation of this feature is taken across 100 days. So they would have one single feature that is corresponding to 100 days. Okay, but what contextually filtered features are saying is they, instead of averaging or aggregating across all the days, they want to aggregate across specific days when some certain contexts occur. So here, context is when student is sitting in a classroom. So if this context occurs, only for those days, we want to compute the average of daily phone interaction time. Why? Because phone interaction time and phone interaction time when student is sitting in a classroom, they are contextually related, right? Like they capture certain behavior. But if we use these unimodal features, they are not much meaningful. They are, of course, useful because they are features, but they don't capture context. So the way they find this like the behavior patterns, for example, in here, interacting with phone and sitting in a classroom are co-occurring together, right? So to find this kind of co-occurrence, they use association rule mining technique. And association rule mining is actually a very simple concept, which will find the frequent associated item sets. For instance, in this picture example, the milk and bread is associated because they are frequently occurring on multiple baskets. So more formally, to find the interesting measure, because there could be many item set, right? If you see this example, apple and beer could be one item set, apple and rice or apple and meat could be another item set. But there would be so much. So, but to find the interesting ones, there are two metrics, support and confidence, widely used. What they do is the support will find the frequent item set. So like it will tell how frequent this item set is in the given data set, right? So in this data set, we have 8 transactions and 3 of them contains this apple and a beer. So we have 3 over 8, which is 37.5% support. And once we have selected frequent item sets using support threshold, next is confidence. Because what, from this apple and beer item set, we can build 2 rules. One is apple implies beer, and other is beer implies apple. So if you take this apple implies beer example, it has confidence of 75% because 75% of the time when apple is bought, we are confident the beer will be bought. So this is a simple step for mining frequent pattern. So based on that, from depression sensor data, frequent patterns are mined in the form of X implies Y. And in here, in the above example, X could be days in which student is sitting in a classroom. And Y could be how often a student interacts with their phone, right? So if that is the case, when calculating this phone interaction time, instead of calculating it for all the, instead of aggregating mean and standard deviation of phone interaction time for all 100 days, we only compute aggregators. Okay, we only compute the aggregation for specific context. So if the only 80 of those 100 days student is sitting in a classroom, then only those 80 is used when calculating the average or standard deviation of phone interaction time. So here now let's talk about how to obtain unimodal feature extraction. So this is a simple form of feature extraction, right? And which was used previously. So first they introduced the concept of epoch. They divide the day into 4 time slots, and that time slot is different for weekday and weekend. So in total they have 8 epochs, and from those for each of those 8 epochs, for each day, they compute the features, all right? For example, exam is a number of phone calls on the morning of Tuesday. So now we have this daily epoch features, but these features are computed for each day. Now we want to aggregate it and get one feature which corresponds to all day. And that is called full features. For example, if there are 90 days and each of them contain, okay, actually, I have an example which is more easy to understand in the next slide, next 2 slides. So first is what I mean by daily epoch features is more visually. So we have, let's say we have 9-week data collection and starts from Monday and ends at week 9 Friday. So we have these epochs for all of them, right? And each of these epochs have 212 features, which is obtained from the sensor or smartphone sensor or Fitbit sensor. And some of them are like aggregated features, which is mean or max. For example, if a step is sampled every 5 minutes or every 10 minutes, then we have some mean or max aggregated features for that. And also they provide some special features for location and steps and Bluetooth. And yeah, this feature is computed for each of these cells, right? So each of these cells have 212 features. and that is what they call daily epoch features. And from daily epoch features, the full features are obtained, right? So to obtain that, so in here, let's say we have maybe 100 days, we are not sure, and that days are averaged using aggregated using mean or standard deviation. So if we had in total 212 features, now we have 424 features because each feature has both mean and standard deviation. And we got rid of this day axis because we used aggregation. And that is, now we have, for each features, we have the 8 epoch. So having said that, now let's see about rule mining and selection and how they extract contextually filtered features. So rule mining, simple association rule mining without any modification is applied to each epoch separately. And among each epoch, they also separate the depression and non-depression group, because the point is to get different rules for depressed group and non-depressed group. So the rules are actually behavior. So here, the understanding is depressed people should behave differently than non-depressed people. That's why they have different set of rules. That's why we have to run association rule mining separately for each group. Output of this process could be, as example, like one rule from this output could be staying at home, low activity on X side, which is used as a context, and as a feature could be being asleep. So because there would be so many rules, like 16,000 per epoch, so they actually have to select some good rules. And good rules are selected with some proposed ranking metric. So the idea is to favor the rules that identify differences between depression and non-depression group. So once those good rules are selected, for those selected rules, they extract contextually filtered features. How? So as we saw earlier, like say selected time periods or epochs for person P that fulfill context X, right? So previously we didn't talk about the person level, and we also said day, but now they actually use epoch, which is more fine-grained level, and they do the averaging only person level. So because we want to describe each person, right? That is our unit of data. So one example could be if the context is staying at home and low activity, and it was observed only in 3 epochs, let's say on week 1, Monday morning, and week 3, Sunday afternoon, and week 9, Sunday evening, then we only select these epochs. And for specific person, right? So this context or this feature could be different for other person. This is done for every person individually. So once we select those epoch, we extract the mean and standard deviation of the features in Y for all epochs. So now this is the last slide before we see the results about the whole pipeline for detection. So coming back to again, they divide the data set into 2 for generating rule, association rule mining, and then for 88 people, they extract contextual filtered features, and then they split it into train and test to build some machine learning model. And they also use the feature selection. Feature selection is applied for full features because like unimodal features are computed from full features, right? but the full features are too many. Like if you see here, 8 multiplied by 400 features are there. So to reduce complexity, they select 181 unimodal features from 8 epoch. So in that case, for some epochs, only 18 features are selected, but for some epochs, 29 features are selected based on mutual information like technique. And then these are now full features, right? Now they are going back to daily epoch features because the association rules are mined through daily epoch features. So based on this 181 total features, or on average 23 daily epoch features, we map, no, sorry, 23 full features, they map them to 20 daily epoch features. So please note this full features is just the aggregated mean and standard deviation version of the daily epoch features. So once they map those, only these features are going to be prepared for association rule mining. So preparation is just recoding it then into 3 categories like low, moderate, and high, because association rule mining doesn't work well with numerical features. And then once the preparation is done, simple rule mining is applied, and then there are too many rules for each epoch. Some epochs provide for 4,500 rules, and some of them provide 26,000 rules. So now we have to do rule selection based on some their proposed metric. And after the rule selection, on average, they are obtaining 13 like rules for each epoch. But please, this is just on average. It differs for different epoch. Like some epochs have 6 and some have 19. But in total, they have like as a result, there would be 105 rules. And using those 105 rules, they get contextually filtered features using the previously discussed procedure. So even though they have 105 rules, those rules on Y side, they correspond to 137 features. You might ask why it's not 105, because on Y set, like X implies Y association rules, association rule, the Y set could contain more than one feature. That's why we have, instead of 105, we have more 137. And then for these are 137 is daily epoch feature. But if we do aggregation using mean and standard deviation, it would be multiplied by 2. So now using those 137 multiplied by 2 features, they obtain these contextually filtered features. And there are also 181 unimodal features, which is traditional way to use features. And hybrid is actually the concatenation of the two. And we can see they have a good improvement. And this improvement, of course, obviously is can be thought, can be credited to better feature representation using contextually filtered features. However, on a cons of this work, it's a little bit computationally expensive because you have to go through all the feature like association rule mining and contextual feature extraction to get this contextually filtered features. Yes, that's all about this work.